Hello students, we are solving problems on balancing. We'll see next type of problem. Okay, I'll read out the problem first. Four masses A, B, C and D are attached to a shaft and revolve in a same plane. Okay, so in last problem we have taken M1, M2, M3 and M4. Here instead of that, okay, he has given in terms of A, B, C and D. So you should take masses in terms of MA, MB, MC and MD, so which are attached to a shaft and revolve in a same plane, and the masses are given, so 12 kg, 10 kg, 18 kg and 15 kg. Okay, in previous problem we had taken, so all the masses are in terms of Newton. Okay, so now it is given in terms of kg respectively. The angular position of masses are given B, C, D are 60 degree, 135 degree and 270 degree from mass A. So in previous problem it was given in between, the masses were given in between, then you were adding. Here in this problem it is given from mass A. Okay, all the angles are given from mass A. Okay, calculate the magnitude and position of balancing mass. That means you need to find out what is the balanced mass M in kg and position of balancing mass. That position means you need to find what is the angle of that mass, balanced mass. Okay, if the balancing mass, if the radius is given 100 millimeter, so the radius of that balanced mass is given as 100 millimeter. The radius of rotation of MA, MB, MC and MD are 40 mm, 50 mm, 60 mm and 30 mm. So radiuses are given in mm. You need to convert those in meters. Okay, how to convert millimeter to meter? Just divide by 1000. Okay, solve by analytical method. Okay, so we'll just draw first what is the mass diagram when they are revolving in a same plane. So this will be MA, okay, which is at 0 degree. Always first mass will be at 0 degree. So next angle is given from MA, which is 60 degree, so that is MB. so MC is given 135 degree from mass A, it is given 135 degree, and MD is given 270 degree. So we are drawing a rough diagram. Okay, so you need not take exact angles. Okay, so we have drawn just a rough diagram. So this is the diagram we will get in. So when the masses are rotating, four masses are rotating in a same plane. Okay, so now we will take the solution. So first we will write what all the masses are there. So MA is given 12 kg, MB is 10 kg, MC is 18 kg and MD is 15 kg. Okay, and these are the four masses and their radiuses are given. Radius is 40 mm is given, but we want it in terms of meters. How to convert this millimeter to meter? Just divide by 1000. That is 0.04 meter you will get. So when you divide 50 mm divided by 1000, you will get 0.05 meter. RC when you divide 60 by 1000, 0.06 meter. RD when you divide 30 mm by 1000, you will get 0.03 meter. Now take the angles. Now the angles are given. First angle will be theta 1 will be, see, I will write this, theta A will be always 0 degree. Theta B is 60 is given 60 degree. Okay, theta C is given 135 degree and theta D is given 270 degree. Now we need to find what is the magnitude of mass M at a radius R is equal to 100 mm. That means when you divide 100 by 1000 you will get 0.1 meter. Okay, so if theta is given, theta you need to find what is the theta. So now next step what you have to do is just multiply MA into RA. So MA into RA when you multiply you will get 0.48. So next MB into RB when you multiply, so that is 10 into 50 you will get 0.5. MCRC when you multiply 18 into 0.06 you will get 1.08. MDRD 15 into 0.03 when you multiply you will get 0.5. 0.45 kg meter. All these are in kg meter. All these are in kg meter. Okay, next step is you need to find what is sine of 0 degree. That is sine of theta A. Theta A is nothing but sine of 0 degree, sine of 60 degree, sine of 135 degree, sine of 270 degree. You will get these values. Sine of 0, you will get 0 degree. Then when you find 60 degree, it is 0.866, 135 degree 0.707, and 270 degree minus 1. Similarly, you find out for cos also. Okay, cos of 0 is 1, 60 is 0.5, 135 is minus 0.707, 270 is 0 degree. So using these, whatever you have found out, so you just substitute these values in the formula and find out the forces. Okay, now when you find the force, so it is given by MARA into cos. In terms of cos it is given. Every term is given in terms of cos. So cos means you should use these values, 1.5 minus 0.707 and 0, and substitute and find what is the component. Okay, so now when I have substitute MA into RA into cos theta A, so MARA is we are getting 0.48 into 1, so into 1. Next 0.5 into 0.5, then 1.08 into minus 0.707, next 0.45 into 0. So when you substitute, so you will get 0.48 into 1, 0.48, 0.5 into 0.5, 0.25, this 1 into 0.707, you will get minus 0.763, plus 0.45 into 0, you will get 0. Okay, so when you add all these values, you will get minus 0.033 kg meter. So why kg meter? Here see MA into RA is kg meter, and cos of this theta will not have any units, so you will get same value, kg meter you will get. Okay, so you will get kg, that is mass is in kg and radius is in meter. Now similarly, wherever you have substituted sine, cos, you just substitute sine, you will get vertical force. Vertical force is given by MARA sine in terms of sine. Okay, sine theta A, theta B, sine theta C, and sine theta D. So now go on substituting the values. So MARA is 0.48, similar to here. So in terms of sine, cos, you substitute sine values. What are the sine values? Are getting 0, 0.866, 0.707, minus 1. You substitute these values. Theta is 0, theta B is 0.86, theta C is 0.707, theta D is minus 1, and MARA is 0.48, MBRB is 0.5, MCRC 1.08, and MDRD is 0.45. So when you multiply 0.48 into 0, you will get 0, 0.5 into 0.86, 0.433, 1.08 into 0.707, you will get 0.763. So 0.45 into minus 1 is minus 0.45. Okay, when you add all these values, you will get vertical force as 0.746. So horizontal you are getting minus 0.033, and this you are getting plus 0.746 kg meter. So after this step, so after finding what is the horizontal component and vertical component, now you find out what is the resultant. So how to find resultant? R is equal to, using this formula you can easily find out what is the R. So horizontal is nothing but minus 0.033, vertical is nothing but 0.746. So when you square it and add it, so you will get 0.557. Okay, So when you square minus, it becomes positive. So when you add this plus this, you will get 0.557. When you take square root of that, you will get 0.746 kg meter will be the answer. What is R? R is also a force. Okay, it is a resultant force which is given by M into R. So M into R is nothing but result. I have just reversed it. M into R is equal to R. So what is the R value? R value is given. So it is given as 0.1. 100 millimeter was given. So when you divide 100 by 1000, you will get, so R value as 0.1. So 0.1 into M you will get is equal to 0.746. R value is 0.746. So when you divide, so it gets shifted here. This 0.1 shifted here down. So it will be 0.746 divided by 0.1. So when you just divide it, you will get 7.46. So what is the unit of mass? Is given by kg. Okay, using this you can easily find out what is the balanced mass. So this will be balanced mass. M is equal to 7.46 kg. Okay, similarly the position we will find out. Position means at what angle, at which angle it is rotating. So that we will find out. For that you will use this formula. Theta position, theta is equal to divided by vertical divided by horizontal force. So when you just take vertical force, which is 0.746, and horizontal if you take minus 0.033. So when you divide that values, you will get minus 22.60. You will get the 0.746 divided by minus 0.033. So when you take this inverse of 22 minus 22.60 tan inverse, so you will get angle 87.46. So that is minus 87.46. That is the position at which that balanced mass is acting. So if you are taking these angles ME, MB, MD, these are the four masses which are acting at 60 degree, 135 degree and 270 degree. So a mass can balanced, these four masses can be balanced by one mass M, which is equal to 7.46 kg at an angle of 87.46 degree. That means minus is nothing but you have to go in this direction. If positive, you have to go in this direction. See, these all are in positive. 60 degree, 135 degree and 270 degree. These are positive. If you want it in minus, if it is in minus, you have to go in this direction. So you can easily balance these four masses. These four masses ME, MB, MC and MD, which are revolving in a same plane by a single mass of 7.46 kg at an angle of minus 87.46 degree. So this is how we are solving when the masses are given in a same plane. Okay, so in next problems, so masses, when instead of giving 4 masses, we will give 5 masses. So same procedure you need to follow, that 4 masses will be given, 5th mass will not be given. So using these same formulas, that is horizontal force and vertical force, so you need to substitute all those 5 masses. So whichever which is not given, that is 5th mass is not given, you take as it is. 5th mass will take as it is M5. Okay, you keep as it is and go on solving. Easily you will get that 5th mass, and angle at which it is revolving easily we can find. So we'll take that problem in the next class. Okay, thank you.